Hello, and welcome to another episode of Celona Field Journal, where we bring you information of a practical nature on private 5G in the enterprise space. Today, our topic of conversation is data privacy, and joining us here to discuss that is security expert Jennifer Manella. Welcome, Jennifer.
Hi, Andrew.
Good to have you back on the Field Journal. So when we're talking about data privacy, it sounds simple on the surface, but as professionals know, encryption is easy to get wrong. What are the key elements of a sound data privacy solution?
Yeah, encryption is definitely easy to get wrong. I think we always say encryption is easy and key management and encryption management is hard. But I'm going to challenge that, data security and data privacy goes well beyond just encryption. I think that's kind of the first barrier to entry, right? You've got to be this tall to ride. Let me at least get on this ride. So we've got to incorporate encryption, whether that's encryption for data at rest or in transit. And it's interesting as we move through zero trust and we move through new compliance requirements. That's the expectations there have been shifting a lot. But the other piece of that is just data privacy as it relates to what you're doing, when you're doing it, how you're doing it, possibly where you're doing it, and the ability to monetize that data by somebody else. So specifically, we can talk about traditional cellular carriers. One of the big things that I've been harping on for a while now is when you talk to CISOs about cellular and private cellular and 5G, the number one concern they have is data privacy, because the carriers do take that data. And I don't mean like they're breaking the encryption and they're diving in and pulling out your intellectual property, but just even the metadata and the habits, right? To be able to see the user's geolocation, where are they? What apps are they using? What are their behaviors and patterns? A lot can be derived from that. And the carriers keep getting slapped, on the hand and slapped with fines for taking that data and sharing it, sometimes, a lot of times selling it to third parties or sharing it without the end user's consent, because we're all just sort of in handcuffs when it comes to mobile carriers, right? What are we going to do? They're all doing the same thing. It's not a competitive thing where we can go, oh, Acme Wireless is doing this, so I'm going to go over here to Gizmo Wireless because they're not tracking me.
Sure, makes sense. And we know that data privacy has an encryption and protection of data has always been a big concern, in particular with wireless technologies, because of the unbounded medium and the ability to potentially capture that traffic outside of a physical boundary, like in the jacket of a physical cable. It propagates. You can't control that propagation to a large extent going out of your facility or out of your property. So how secure is the data on a 5G LAN connection? This is a common question we get from a lot of enterprises that aren't familiar with cellular technology, apart from their consumer perspective. So when they're looking at adopting it for their business practices, data privacy always comes up as a huge talking point.
Yeah. Well, okay. So let's go back to the encryption thing, because I know I get on the soapbox about the other privacy stuff, but encryption is again that barrier to entry. So in the Wi-Fi space, let me just give a little bit of sort of level set so we're on the same page here. And Andrew, I'm definitely not saying anything you don't know, so this is for the listeners. Just kind of level setting till right now. Most Wi-Fi networks are on WPA2 version of the security suite. So WPA3, which is the new one, has been out for a while, but really coming into this year now is I think where it's just really starting to get more widespread adoption, being supported in the infrastructure products and the endpoints, et cetera. So most networks are still in WPA2. I think you'd probably agree with that. So a couple of things there, right? I'm going to put guest and open stuff over here. We don't care about that. It on that version doesn't have encryption. So let's talk about the other two types of Wi-Fi networks really quickly, which is we've got the personal class, which just means it's secured, air quote, with a passphrase. So that's when you connect to a network and it pops up right there, and it asks you, to put in some kind of network key. That's a personal network. And then, of course, we have the enterprise class of network, which is the 802.1x secured one. And that is the one that requires the radius server and directories and everything else on the back end. And so when we look at the encryption with WPA2 with these two things and the security related to them, we have a few challenges. And the challenge is probably more specifically, or most specifically, on that personal class network, where we've gotten to the point now where we've said basically a WPA2 passphrase or WPA2 personal network is always going to be vulnerable. So with most of the Wi-Fi networks on that type, they're very susceptible to dictionary attacks, including offline dictionary attacks. The code that you're typing in is actually the encryption key. So if it's a short code, you've got a short encryption key, which is easy to break in a myriad ways. And that key is shared among the devices on the network. So let's take a hospital where you've got all of the biomedical devices on a network or two, and they're sharing keys. A couple of things there is when you do break into the key, and you will if you're trying to, for WPA2, you're going to be able to decrypt and or intercept other endpoint and user traffic, as well as past traffic. And so that's obviously a huge concern, right? Because among many challenges is, from a security professional standpoint, for somebody that's an analyst or working in a NOC or a Wi-Fi architect, you don't know that happened. You don't know that that's been compromised unless they initiate something else. So that's a huge problem. Then we can get into, now, I should say, with WPA3 personal class networks, a lot of those concerns are removed. So WPA3 is very good. It doesn't matter the type of networks you're going to use. But on the enterprise class, we still have challenges because the SSID, the network that you're connecting to, is its own broadcast domain. And unless you do some special vendor stuff, the group keys are shared. And so there's opportunity even to attack, using sort of an insider attack, those networks as well. So that persists with WPA3. It's just the way that protocol works. So from an encryption standpoint, we have had and will to some degree continue to have challenges with this. Now, to answer the question about the cellular, I've said WPA2 is not so great. WPA3 is much better. On the cellular side, the minimum that I have seen everybody do is the equivalent of what we're doing on WPA3 on this new Wi-Fi security suite. And then there are some, I think, kind of upcoming relatively soon roadmaps to increase that even further and get to what we call quantum. What is the word I'm looking for? They're quantum resistant protocols, cryptography on the cellular side as well. So we're on par with the strongest Wi-Fi security we have right now, with the opportunity to enhance that further.
Yeah, so it sounds like, cellular can limit the scope of potential impact, as well as the historical, let's say, data archival or capture of traffic compared to Wi-Fi. Like you mentioned, one of the things that is a big, huge issue that I've experienced is with Wi-Fi is if you're implementing devices and applications that have high performance requirements, oftentimes that means you're sacrificing security to get that performance. Say you may need high mobility and high roaming, or very high quality of service for voice or specific, let's say warehouse application, as one example. You could go down the route of 802.1x, but then you get into a world of complexity with how that interacts with roaming and the performance and security trade-off. Whereas then if you drop down to the personal or pre-shared key version of Wi-Fi, you're opening up yourself to that data gathering and archival. And then once they crack that key, they can go look at all the past traffic that they've gathered for days, weeks, months, however long they've been passively monitoring your network.
Absolutely. Yeah, absolutely. It's a huge concern. So in the world of Wi-Fi, we've got those three types of networks, and then there's different implementations within each of them. So you get a whole rainbow of security strength from nothing to pretty strong. And I think in the private cellular, everything I've seen is in out of the box. It's in this very strong range, right? And there is no opportunity to downgrade and to do something lesser than that. So we're starting at a much better place.
So to kind of level set that WPA3 or that cellular SIM authentication and encryption, what is that stronger? What is that? What are the characteristics of that strong security that are inherent in both of those? I'm assuming one would be unique identity tied to a unique encryption key that is can't decrypt other traffic on the network apart from that one time-bounded session for that authentication session.
Right. Yeah. And you know, in Wi-Fi, we have a lot more of, I'm going to be careful about using this term, peer client communication opportunity. So there's a lot of opportunity for endpoints to join a network or even initiate something ad hoc with each other that we don't have control or visibility into. So that's another sort of element within something that is eliminated out of the box with the private cellular solution. That's
a good point. I never even thought about ad hoc or peer-to-peer connections. I'm recording this on a Mac. We have AirPlay, and you can start up AirPlay and see all the other devices around you and potentially query them to get information off of them or information like that. So and Bluetooth and all sorts of other peer-to-peer type of.
Oh yeah. When I was writing the book, I was keeping in touch with the pen testers I work closely with and other researchers in the security space for Wi-Fi stuff. And we were, there's a whole section of the book of that kind of gets on the soapbox about those zero conf protocols like Bonjour and the MDNS and things that were designed for home use that are now in the enterprise. And it was pretty interesting because I thought I understood the vulnerabilities in that pretty well, but I went back and reread RFCs and talked to pen testers, and then really had a an oops moment, because it is much more serious, and in fact, it is the number one way that attackers and pen testers get into a Wi-Fi network. It's the first thing they try.
Very interesting. Yeah, as network infrastructure gets more and more secure, the clients become the point of entry more and more, right?
Yep.
And in cellular, we don't have any concept of peer-to-peer connection. A cellular connection is always between a user endpoint or a UE, which is the client, and the infrastructure, which is the base station or the access point that is controlled by then the enterprise. And so data is always kind of going through the enterprise to get to its destination, so you can have visibility and control over that traffic.
Right. Yeah. So you can allow on cellular, you can allow two endpoints to talk to each other, but you're allowing it. You're in that data path to allow it and block it or allow it and log it, etc. Whereas in Wi-Fi, you don't necessarily have that control.
Okay. Interesting. So maybe we'll wrap up with this. How does data privacy on an enterprise 5G LAN potentially differ from a public mobile network or a private 5G network that is built by a mobile operator? Because we see those becoming more commonplace out in the market as well.
Great. I'm going to get back on my soapbox for just a second about that data privacy thing, because I think this is important to understand if you're considering private cellular, and that's that there's different models of deploying it. There's different types of delivery, and there's different types of infrastructure. And so, when I'm talking to clients and to organizations, I tend to put Celona on one end, which is works very much like enterprise Wi-Fi, down to planning it and being able to deploy it yourself within the environment. It's got power over Ethernet. It looks and feels a lot like a Wi-Fi AP, right? And so it then sort of just kind of becomes part of the enterprise network and is managed by the same teams, which is very different from kind of the other end of the spectrum, which is some of the deployment models and solutions that are coming from traditional cellular manufacturers or providers, where that equipment is deployed physically down to like the connections that they have, more like it would be out in a public cellular scenario. And so then you kind of talk about the range of the management and delivery models of, okay, you could have something again like Celona, where the enterprise fully owns and manages that. The enterprise data is never going anywhere without the enterprise's knowledge, right? Celona doesn't see the data. You're not selling it to third parties, et cetera. That packet core is not, shared up somewhere else, which is very different than a model where some third party, and maybe it's a carrier or maybe it's some other third party, is fully managing that. And the packet core is in their purview, and you're just sort of like a tenant in a bigger space, in which case your data is, air quote, leaving your organization. And I mean, logically, it could be also physically as well. It's leaving that. And then you don't know how that data is being used. And again, it's not about them reaching in and breaking your encryption and stealing out individual, emails and stuff that you're sending. But by watching the behavior of endpoints and people and devices, the applications that they're accessing, a lot can be derived. And this is a huge concern, especially for companies that have a lot of intellectual property that are looking to retain their commercial advantage, and maybe the subject of an attacker looking for certain types of entry points into their network. So huge difference between, kind of having that full control, ownership, management of the enterprise, just like you would Wi-Fi or your switching and routing, versus having that from a carrier or somewhere else. And again, so great timing, because it was just about a week ago, the chairwoman of the FCC wrote a letter to the carriers, and I think they have responses due back sometime next week, basically saying, she's done with this. The data privacy here has to be under control. They've already been hit with, I think it was, I actually had this up earlier, $200 million in fines for selling access to the customer's location information. So it's not theoretical that they could do it. They have been doing it. They are doing it. And it's a huge concern.
Yeah, definitely relevant for those customers that are looking for a private 5G network for very mission critical, business critical, and their intellectual property type of data within their environment. So definitely a highly relevant topic. Thank you, Jennifer, for joining us. As always, thank you listening to this episode of the Celona Field Journal. We have an additional couple of security episodes coming up with Jennifer. Please tune into those on our YouTube channel. And if you're looking at enterprise or private 5G solutions, can always start learning at celona.io/journey, where we have a lot of information available that we put out there for you. So looking forward to our next episode, and thank you for watching.